kick off is Cory Fields, who's a researcher at the MIT Digital Currency Initiative, and he's going to be talking about how everything's broken. Thanks, Cory.
Thank you, Asim, and thank you everyone for coming. Can you hear me okay? Okay. So what does everything is broken mean? It's a very clickbaity title for a presentation, I realize, but the reason I say is because it's become kind of a mantra for at least for myself, but for the people who hear me banging my hands on the desk and screaming all the time. So I should introduce myself quickly. I'm Cory Fields. I work for the here at the MIT DCI. I'm also a Bitcoin Core developer. I'm less active these days there because I'm kind of spending some time looking at higher level stuff. So everything is broken to me is a sentiment that most Bitcoin developers feel in some way, and I think it's because in talking to Michael especially, I said everything is broken. He said, "Yeah, of course." So I do want to give a quick disclaimer. So I'm going to be speaking ill of a little code and some development processes. What I'm not trying to say by any means that Bitcoin Core does not work well. I think Bitcoin Core is kind of state of the art and goes to extreme lengths to do things as safely, as securely, and as non-broken as possible. I'm mainly talking about just how bad the state of development for this type of insanely secure software is. So I was asked a few years ago at the MIT Bitcoin Club here how I thought Bitcoin might die. What would be the end of Bitcoin? And the pretty common answer to that, there's the 51% attack, that's the stuff listed in the white paper, a protocol flaw, things, something like SHA-2 could be broken in the future, ECDSA could be broken. We've had bugs in script before. The earliest versions of Bitcoin actually had there are some opcodes that would allow you to print money to do some very strange things. Government intervention also comes up relatively often. There's a lot of mining power concentrated in China. It kind of begs the question sometimes: what happens if China just decides they're really done with all of Bitcoin? My answer though is I believe that the most likely kind of just sudden death scenario for a cryptocurrency like Bitcoin is an accidental bug, something introduced kind of internal to the system. And the reason that I say that, and I think that Ethan is going to go into these in a little bit more detail later, but I've been involved in some of these really nasty bugs, and some of the people in this room have been involved with these really nasty bugs. And like I said, I'm not going to go into the specifics of them, but I think both of these bugs, I think both in 2018, had the potential to bring down the respective chains or the respective currencies. So there was a Bitcoin Cash bug that I found and disclosed, and it kind of, I like to think that it kind of kicked off a discussion about responsible disclosure in these types of systems, as well as just how you deal with them generally. And I was a little smug for a few months until we ended up being affected by a pretty similar bug in Bitcoin Core. There's a bug that potentially allowed for money printing, allowed for coins to just appear out of thin air. And it's really important to step back and ask, number one, how do these things happen? But number two, how can we prevent them in the future? And I think this illustrates pretty perfectly why everything is broken. Bitcoin developers and developers of these highly critical pieces of software, we don't just get to deal with the code that we're looking at. When you review a pull request for Bitcoin Core, it's not just that C++ code alone that you have to consider. There's nothing in isolation in the system, and that's terrifying. We have dependencies. So OpenSSL was mentioned earlier. So Bitcoin Core actually depends on OpenSSL, and in the past that really bit us in the ass. There was a potential fork. We kind of came together quickly and mitigated, but that was a potential Bitcoin doomsday scenario just simply by the fact that we rely on OpenSSL. We've seen bugs in libc implementations, get host by name, DNS calls. DNS is always fun, and DNS lives in libc, lib, std, C++. We've seen threading issues. We couldn't migrate from one version of C++, 98 to 11 because of issues here. Compiler bugs are fun. Bitcoin Core has actually exposed bugs in GCC, miscompilation bugs, where you have perfectly valid C or C++ code, and it turns into assembly that does not do what you think it's going to do. We've had kernel bugs where with socket allocation and socket reuse, CPU bugs, things like Spectre meltdown. We have to consider the side channels. We have to be very mindful of the way that we develop around all of these things. RDRAN, things in CPUs we don't trust. This is like a constant ongoing question, and so. When you want to pull a kind of substantial change into Bitcoin Core, this is the stack that we have to look at. And it's daunting at times because, especially for developers, some developers know code really well but have no idea how a compiler works. And so it requires a whole lot of collaboration to try to get a lot of this stuff right. So I would like to illustrate a case of, I think, kind of as what illustrates exactly what we're dealing with when I say that just software development in general is broken. So this is go to fail. This was an iOS bug a few years ago, and you look at the code. You can with or without the highlight. It's not at all hard to determine what went wrong here. But I would assert that the developer who added the go to fail here did not make a mistake. I don't think that this is a developer bug. I think that the system let down this developer because in so many ways, this code should not have been able to ship. In every way, this code should not have been able to ship. It should have been caught by a linter first in some way. Actually, the compiler should have yelled about something, then a linter. But I would go further than that and say that this code should not allowed to be, this code should not exist. It should not be allowed to exist. Enter Rust. So Rust is a drum that I've been banging a whole lot lately, and I think a lot of people in this room feel the same way because it in a lot of ways just feels like a solution to a lot of this stuff. And in some ways it's because it's architected with learning from the past, but in a lot of ways it's just newer and just kind of better. But I don't want to focus on Rust, the programming language. I want to focus on Rust, the idea, and Mozilla and Rust. So for those of you that aren't familiar, Rust is a programming language that came out of Mozilla. I think it was originally started by some Mozilla developers, maybe 12, 13 years ago. Right around 10 years ago, it became an official Mozilla project. The idea being, if you can recall the internet 10, 15 years ago, it was a buggy, crashy, exploity place, and not to say that it's not anymore, but it was at least kind of more Wild West that way. And so if you're a developer working on a system like that, you just get tired of it. You get tired of chasing a null pointer dereference all day, every day, or trying to track down your data races. So I think what's interesting about Rust is that the Mozilla Foundation and the people generally involved had the idea to say, so we're working on this stuff now, and we're fixing it as we go, but let's look like way, way out, and how can we totally avoid these issues completely? This is not possible in Rust. This bug, just by nature of Rust, there is no go-to in Rust. And the reason that there is no go-to in Rust is because there should be no go-to in Rust. Everyone in this room knows, I hope, why go-to is so scary. And of course, there will be some edge cases. Somebody will want to say, it's helpful for error handling, whatever. It's not robust. You can say it's useful, but it's not robust. So I'm of the opinion that we're at a kind of critical moment where we have this ability to look at Bitcoin and look at Bitcoin development like Mozilla looked at Firefox and say, we're chasing the same bugs, we're fixing the same problems. What is our 10-year solution to things? What is the way out of the same review processes that we have now. You can add more people, but again, everyone in the room, I assume, knows adding more developers does not make better, faster code. That's unfortunately not how it works. So I think it's a matter of improving the tooling, improving the language, and I like to think of this as kind of a spectrum. So on one side, you have like as generic and general purpose as it gets, and that's pretty close to what we have now, or that's what Bitcoin was in the beginning. It was one CPU, one vote. It was a Windows program, I believe, that you would run. Now we have ASICs. We have very custom mining hardware. We have hardware wallets. It's not absurd to ask, will we ever run Bitcoin Core or whatever the Bitcoin entity is on a dedicated piece of hardware that only this hardware can run the consensus algorithm? I think it's absurd. I don't think we'll ever go that way. But I think it's interesting to consider if we're here now, does it make sense to just always push in that direction? Always push towards more custom, more domain specific, because you can kind of guarantee general purpose code, general purpose algorithms and hardware have trade-offs that we don't want to trade. So I said I don't want to talk about Rust as a language. I want to talk about it kind of as a process that Mozilla went through. It also is a cool language, and it's not at all surprising to me that Bitcoin developers, and I think a lot in this room, have shifted, if not somewhat, to like primarily working on Rust. And it's because Rust is a language that provides certain guarantees that C++ doesn't. The Bitcoin Core is currently written in C++. So as next steps, I think it's very, very important to look way forward to how we can move away from some of these problems, but also use the 10-year program that Mozilla has put into place. They've solved a lot of these problems for us. So one thing that we are working on is there's currently a pull request. Jeremy Rubin and I have kicked off a PR to actually get Rust code into Bitcoin Core. The idea being, if there's new code, so Matt has written a whole lot of things actually to try to take advantage of this. That the idea being, if there are segments of code, if there's new code that we can add that is totally kind of sandboxable from the C++ code, why not just go ahead and start with something that gives us better guarantees? So there are technical problems with that. There are social problems with that. There are a lot of problems with moving in this direction, but I think it's pretty clear that this is the direction that things are going. So this is actually a discussion that I think will be kicked off like very soon, like in the next week or so, as far as what is the direction of this. Do we? There are a whole lot of open questions for exactly what Rust and Bitcoin would look like together. So this is a very condensed version of this rant, by the way. So there's a much longer one it's essentially the idea, or at least one idea that I've had to move forward is to try to take advantage of this stuff, and it's to take advantage of Rust and the progress that projects like that are using. And what's interesting is that other things just fix themselves. So the idea of just going and contributing to Rust at the moment, contributing to the Rust language at the moment, could potentially end up fixing Bitcoin. We've done that. Lots of Bitcoin contributors contribute to upstream libraries. Upstream, I've contributed a good bit to GCC and to Clang and to MenuTils. I think it's time for us to do that, but apply a kind of a rigorous, researchy type of approach to it. So if that resonates with you, if that's interesting to you, we've been having some discussions about this. Like I said, it does tend to resonate with Bitcoin developers. And so when we have these discussions, solutions kind of come up pretty quickly. So in the last week or so, there have been some people that I've been speaking to potentially get some of these projects kicked off. So I think it's a good time to begin to collaborate on what is a 10-year project. And so if that's interesting to you, then come talk to me about it. Otherwise, we'll just live with everything broken for a while. That's it for me. Yeah, one over there.
Hi, I'm just curious as to what are your thoughts on writing a blockchain program in something with a type system even safer, like, I don't know, Haskell or something?
I'm all for it. So Rust is an example. It's a bandwagony thing, like for sure, but it's got momentum. And I think we're going to get a lot more people working on Rust than Haskell.
Okay.
But that's not so. Any drop-in that gets us tighter security. I mean, I think that like I said, it's a spectrum from where we are now to from general purpose where we are now to much less general purpose. So I would expect for sure better, tighter languages to evolve, and hopefully we could be a part of that.
Over here, to your right. So to what extent do you believe that it is feasible to maybe make a domain-specific language just for blockchain?
I think very possible. It's a little complicated. I think that a domain-specific programming language probably isn't what emerges, but ways to reason about specific constraints of the system, I think may emerge. So a language to document a peer-to-peer protocol and exactly how things go back and forth. For example, like right now it's ad hoc. But if you want to test it, you simulate the whole thing. It's not at all clear. So. As much as it would be nice to have an all-inclusive language that it just kind of does everything for you, I think you'll want code proving of this stuff would work a little bit different from formal verification of this stuff, but all somehow tied together.
Do you have you here?
Or am I lucky? Thank you.
Hey. Have you considered tools that are used by other industries that write critical software? For example, there are a lot of tools that cost, I don't know, thousands of dollars that are static analyzers for C, whatever. I don't have experience with those tools, and they are not at all common in the open source community, but I guess there is some merit to those things because they get used in other areas.
So same, I have the same experience, and actually when I say come talk to me about this stuff, it's very much what I'm inviting. So an example that I like to give, we've seen a lot of cryptographers embrace cryptocurrencies and Bitcoin in particular because it's a way that Dan Bonnet in particular it has kind of found that it's a way to get your new shiny crypto tested in the wild. It's kind of a bridge to get it out in the public, and it wouldn't surprise me at all if there are a lot of CES, formal verification people or language people that would be interested to get involved with this. They haven't yet. So if we throw out the incentive that this will get used for Bitcoin, this will get used for cryptocurrency, maybe they're interested.
So it's really neat that you're working on moving Bitcoin Core over to a safer programming language. I'm actually working
considering.
Considering. So I'm actually working on a safer programming language for smart contracts.
Okay.
So it takes some of the ideas from Rust and some ideas from elsewhere, and provides some additional safety guarantees. So I just think it's really neat that we're looking at improving safety with language methods at all the different levels of the stack.
Right. So that's like the question about domain-specific languages. So so something like that may be totally useful, just as a very small part of something in a bigger kind of proven whole. So yeah, I agree.
I had maybe a little bit more of a comment than a question. Sorry, Cory. I would note, however, when we're talking about domain-specific languages here, there are very different use cases even within a cryptocurrency application like Bitcoin Core. For example, we're talking about moving some pieces of the kind of networking stack to Rust, where it makes a lot more sense to use something like Rust, whereas the consensus bits, because the requirement is more about well-definedness of exactly how all of this code behaves and less about the kind of inherent safety of the language, although that is also important, it's not feasible to move the consensus code to something like Rust. It might be more feasible to look at something like Ada or Haskell or another language like that that's much more carefully well-defined than Rust. Similarly, of course, there's very different constraints when you talk about smart contracting languages and stuff like that. So there are very different domain-specific pieces, even within just a single kind of cryptocurrency application.
Questions there?
So I do want to thank you, Wasim, for reminding me. So we are actually spinning up a little group, a little kind of subgroup of the DCI to begin thinking about these questions and potentially working on them kind of independently somehow. So basically there needs to be a space where Bitcoin developers don't feel like they have to be plugged into the day-to-day pipeline. That's feedback that I get pretty often, that it's hard to work on 10-year out stuff when everything is on fire. So hopefully we can establish a place where we can take kind of an academic, rigorous look at some of these questions without having to interrupt the day-to-day flow. So please come talk to me if you're interested in any of this at all. Thanks.
Thanks very much, Cory.